Section 5.4 is called the sum and difference formulas. So our objectives, our goals are to use the sum and difference formulas to evaluate trig functions. And we're going to also use sum and difference formulas to solve trig equations. So to solve equations that are not explicitly written on the unit circle, so for angles that are not like pi over 3, pi over 4, pi over 6, or multiples of those, we have formulas that we can use to write or to relate them to angles that are on the unit circle, and that add or subtract to the angle that we can't use. So here's some patterns. We got sine of u plus v. So u is going to be some value, v is going to be another value. It's going to be equal to the sine of u times the cosine of v plus the cosine of u times the sine of v. Wow, that's a lot. Now the sine of u minus v, so the same things where u and v are just some angle measures that are on the unit circle. It's going to be sine of u times the cosine of v, in this case minus cosine of u times the sine of v. Now similar for cosine, we've got cosine of u plus v. And this one's got kind of a more consistent pattern. It's cosine of u times the cosine of v minus the sine of u times the sine of v. For the cosine of u minus v, so the difference of two angles, we've got cosine of u times the cosine of v plus the sine of u times the sine of v. The tangents are a little more complicated, but we're going to make it work. The tangent of two angles, u plus v, is equal to the tangent of u plus the tangent of v, all that divided by 1 minus the tangent of u or times the tangent of v. And similarly, the tangent of u minus v is the tangent of u minus the tangent of v over all of that over 1 plus the tangent of u times the tangent of v. Yikes, that's a lot. Now let's actually figure this out, how to apply it in an example. So we're asked to find the example of sine of pi over 12. So to do so, pi over 12, not on the unit circle, we're going to have to figure out angles that are on the unit circle that add or subtract to give us pi over 12. So I go to the unit circle. I'm going to focus just over here once it shows up on your screen. There we go. I'm going to focus over in quadrant 1. We got pi over 3, pi over 6, pi over 4. I don't know why I read them in that order, but those are the angles we have. Now, none of those are over 12, but we can make them over 12. So, for example, pi over 3 is the same as 4 pi over 12. It's just an unreduced version. Pi over 4 is the same as 3 pi over 12. And pi over 6 is the same as, 2 pi over 12. So we got to think about things in terms of over 12. That way they all have a common denominator. Now, we've got a couple options here. We're trying to figure out two angles. When we combine them, we're going to get pi over 12. Because again, that's what we're looking for, the sine of pi over 12. Now in this case, we got to figure out which ones are going to add or subtract. Now, none of those add, so like 4 pi over 12 plus 3 pi over 12 gives you 7 pi over 12. Not what we're looking for on this example. Same 3 pi over 12 plus 2 pi over 12 doesn't work. 4 pi over 12 plus 2 pi over 12 also doesn't work. So probably going to have to do some subtraction. You can either do 4 pi over 12 minus 3 pi over 12 or 3 pi over 12 minus 2 pi over 12. Doesn't make a difference. So I'm going to say pi over 12 is the same as, I'm going to do 3 pi over 12 minus 4 pi over 12. In other words, pi over 12 is equal to pi over 4 minus pi over 6. So instead of saying the sine of pi over 12, we'll say it's the sine of, pi over 4 minus pi over 6. Now relating it to what we saw on the previous page, it's kind of like our pi over 4 is our u, our pi over 6 is our v. So using the sine difference formula, sine of u minus v, it's the sine of u times the cosine of v minus the cosine of u times the sine of v. Let me write that out again. So again, sine of u minus v is equal to the sine of u times the cosine of v minus the sine, I want to make sure I'm using the same order that I have it on the other page. Sine of u, cosine v. Okay, I do the cosine first. So it doesn't make a difference. I was going to do sine of v, but we're going to do cosine of u times the sine of v. So plugging that in, the u value, we got sine of u, so we got sine of pi over 4 times the cosine of pi over 6 minus the cosine of pi over 4, the u value, times the sine of pi over 6. Now, the sine of pi over 4, if you look in the unit circle, is the square root of 2 over 2. The cosine of pi over 6 is the square root of 3 over 2. On this other one, cosine of pi over 4, also square root of 2 over 2. And then sine of pi over 6 is 1 over 2. So we end up with root 2 over 2 times root 3 over 2. Multiply the numerators together, we get square root of 6. Denominators, 2 times 2 is 4. Minus the other one, root 2 times 1 is square root of 2. Denominator, 2 times 2 is 4. Now, we can combine this into one exact fraction. We got the square root of 6 minus the square root of 2, all that over 4. So the sine of pi over 12 reduces all the way down to, in the most exact form, the square root of 6 minus the square root of 2, all of that over 4. For example 2, we're going to try to find the exact values similarly of 7 pi over 12. So I'm going to go back to the unit circle. Look at the ones that I already wrote there. We got 4 pi over 12, 3 pi over 12, 2 pi over 12. We got to figure out a way to add or subtract 2 of those to get 7 pi over 12. Well, let's add 4 pi over 12 and 3 pi over 12. So I'm going to say cosine of pi over, or 7 pi over 12 is the same as cosine of 3 pi over 12 plus 4 pi over 12. In other words, it's the cosine of, sorry, my stylus got loose, pi over 4 plus pi over 3. So we're going to do the cosine formula. We've got the cosine, let me write this off to the side. So cosine of two angles, u plus v being added together, is equal to the cosine of u times the cosine of v minus the sine of u times the sine of v. So in our case, we got the cosine of pi over 4 plus pi over 3. And so we're just going to replace all the v's, or sorry, all the u's with pi over 4 and all the v's with pi over 3. So we got cosine of pi over 3 times, sorry, I guess it doesn't make a difference which order I go in, but I got to be consistent. The cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. The cosine of pi over 4 is square root of 2 over 2. The cosine of pi over 3 is 1/2. Minus the sine of pi over 4 is square root of 2 over 2. The sine of pi over 3 is square root of 3 over 2. Cleaning up these fractions, we got root 2 over 2 times 1 over 2. Our numerators multiply to give us square root of 2. Denominators multiply to give us 4. Minus, in the other one, root 2 times root 3, and the numerators gives us root 6. Over, denominator, 2 times 2 is 4. And it's pretty similar to the previous one, except the numbers are flipped around. So we end up with root 2 minus root 6 all over 4.